Good morning, and welcome to our webinar, Getting the Most Out of Fusion to Create an Optimal Design. I am your presenter today, Daniel Douglas. I'm an implementation consultant here at D3 Technologies, and I am a designer, a maker, and an aerospace nerd. The purpose of this webinar is to showcase features of Fusion 360. And I'm going to do that by looking at a project that I went through working out of Fusion 360. Now, my objectives for the project were to revitalize a crashed drone, design a lighter frame for the drone, and add some auxiliary features, basically be able to add attachments like a camera if I wanted to, or a different type of landing gear and so on. And this is probably the real reason why I did it, to prototype on a Markforged printer. I love those printers. So that was my reasoning there. In this webinar, I'm going to try to cover 3 areas within Fusion 360. I'm going to talk about design, as abstract as that is. I'm going to talk about 3D modeling, some of the tips and tricks and best practices. And then I'm going to talk about 3D printing, both designing for 3D printing, exporting STLs, and working between Fusion 360 and other softwares, such as, in this case, Eiger, which is a browser-based proprietary slicer software for Markforged. All right, just as a run through of what you're going to see in this webinar, I'm going to go through design, talk about reusing existing ideas. If it's already there, ain't broke, don't fix it type deal. Anticipating design errors, which, to be honest, if you're working in a team with humans, then there will be errors and there will be problems. So planning and having a nimble model or assembly and a nimble process that allows you to adapt is something that I look for and that I try to develop. And planning for iterative development. So knowing that you are going to go back and make changes again and again and again, and making it easier and facilitating that in your model and in your assembly. For 3D modeling, I'm going to talk about planning for change. And this is essentially the core of parametric modeling. Keeping dependent features healthy. So if I have a feature that changes a previous feature, I want to make sure that if I make a change earlier in my timeline, that I have a cascade effect that doesn't disrupt my model downstream. All right. I want to talk about shifting from single body to assembly design. That's something that is a little bit different in Fusion compared to other 3D parametric softwares, because in Fusion you can have your assembly inside of a single file. And you have internal referencing, as opposed to most other 3D parametric softwares that use external referencing for bringing parts into assemblies. And as far as 3D printing goes, I'm going to talk about designing a part for a Markforged X7, which is the printer I was using. I'm going to talk about adjusting your plans and ideas based on what you know is going to happen with the material, both the flexibility and the nature of the material, but additionally, the kind of tolerance issues you will have with printing. And so we'll talk about thinking ahead for that. I'm going to show you how to export an STL from Fusion 360, and there are a couple ways to do that. And then I'm going to talk about setting up a build in Eiger, which is, once again, the proprietary slicer for Markforged. All right, so back to this drone right here. I crashed this many times, and I realized that I needed a replacement. It wasn't flying right anymore, and the frame was shattered and glued together in it, and I couldn't fly it. So in addition to that, the motors were getting tired, worn out. They were brush motors, so they have a limited lifetime, but I thought maybe I could extend that a little bit and get a little bit more fun and learn some things. So decided to create this. Now, the first thing I had to do is determine what to keep and what do I want to replicate that's already there. This is part of reusing ideas. You don't want to reinvent the wheel. You want to reuse what you have, and you want to be efficient. Now, let's talk about this. I'm going to go over to Fusion. And one moment. Here we go. Now I'm inside of my part here. I started out with just modeling a single motor mount. I wanted to get as close as I could with a single part, and I was planning to do prototyping. So I wanted to be able to cut my model up into pieces and print one piece at a time and test it without printing the entire chassis and wasting material. And that is what I did. However, because I was working on it over time, I kept referencing back to my initial sketch, and I made most of my alterations to that initial sketch. My process here my process for creating this model was based on the requirements of the existing chassis. So if I can switch back here. I was aware that I would need to be using fasteners because you'd have a lot of vibration and a lot of torque. And so I knew that I would have to mount this motor assembly here directly to the frame. The existing chassis has a lot of plastic that protects the gearbox and protects the components. And I knew that in order to reduce the weight, I would have to eliminate a lot of that. So I did so. I knew that I would need to keep that motor assembly. So I mimicked the interior of the chassis for the mount points. I try to do so as accurately as possible. Even with that, the tolerances of printing on a Markforged required me to try a couple of different iterations before I could get an accurate matchup to the part. All right. Now we're going to examine my timeline here. I'm going to roll it back to this point. Once I had created a rough replica of the mount, I then printed this and made sure that everything lined up. A part of the prototyping process means that you will have errors, expansion of the material, especially with 3D printing and so on. I ended up doing multiple iterations and stepping back and forth. So I'll show you those. Now, in order to test the threading, I did that second. I reduced some material and I made a few adjustments to the location of those fastener posts. Let's see. Now, it took me a few tries before I could actually get it to mount exactly. And even then I had issues with vibration that were shearing off the post. So then I created very large radius fillets around the base of the posts in order to give them more strength, and it made them very robust and got rid of my shearing issue. Now, after I prototyped the mounts, I had to move over to the actual control board. I wanted that to be as safe as possible. Variety of reasons for that. I didn't want to crash and immediately damage components and never be able to fly again. So I wanted to be in the safest spot on the chassis that I could put it. So the first thing I did, once again, was determined that I need to replicate this mounting system here. And I determined that I would need to probably print it as small as possible so that I could do multiple iterations and not waste a lot of material, which is what I did. And I allowed the board to be mounted in the lower part here, and then I created a cross section to slide the battery in. And that gave me a lower center of gravity. This is actually the bottom of the quadcopter, and the top would be on the ground plane here. So I'm going to switch back over to Fusion. You can see the fillets that I added for increased stability and the threading. Now here, as I move back and forth on my timeline here, you can see the process. I began by placing the mounts, creating this this perforated base for so that I have reduced material, and I built it up. Did that H junction up there on the top. I knew that I was 3D printing, so I kept that in mind. I realized that my layers would be would create a weakness on a vertical rise like this. So I tested a couple of different on several occasions just to make sure that it could withstand a variety of stress levels. The material that I was printing with, onyx, which is a Mark Forged material, is extremely resilient and can take a lot of damage. So as we move forward, you can see that there are dependencies that I had to account for, and I had to go back and double check and make alterations. There are a lot cleaner ways to go through this process, but I had not designed a quadcopter frame before, and so I wanted to keep as many of my parts together as possible. Now right here, this is the component that I exported for printing, as in the previous PowerPoint slide there. And I will show you how you export this. I have two options if I want to export an STL for printing. The first is I can go and find that body or component underneath my browser menu. I'm going to right-click on that body, and I'm going to go down right there. It says Save as STL. Now I can save it out as an STL, and then I can upload it, or I can put it on a flash drive, whatever I need to do. I also have an option under the ribbon here, the Make drop-down menu. Right here it says 3D print. So 3D print versus export and STL, they are exactly the same. They both open this menu. Now, if I have my selection, I can preview my mesh. There we go. In addition, I can choose to send to a 3D printer utility, which is an excellent feature. So in this case, I could choose Mesh Mixer, Print Studio, Preform, or if I have another, such as Cura, I can select that, set that up, and I can output directly to it. That's a great feature. Now, in this particular case, I don't need to do that because I am using a browser-based slicer. So I just press OK. It gives me a choice to save, and so on. From there, I would then go to Eiger, which is the browser-based slicer, and I hit import STL. I select that STL, it imports it, and then I set it up. So here I have a couple of builds. Let's click on the component housing. Now within Eiger, and I'll just briefly touch on this, I can see what my dimensions are, have my estimated print time, cost of material, mass, and so on. Over here I can select my material based on the machine I'm using, which in this case I'm using the X7. And I could choose reinforcing material, which I'm not doing. I'm using onyx, which for my purposes was perfect, very flexible, very durable, and very good at absorbing shock. Of course, if you brought in the model with the incorrect orientation, you can adjust it accordingly. All right, so after I had printed, tested, and gone back and forth making minute adjustments, which I had to do, I had to move these jaws further apart. I had to adjust the spacing. I had to reinforce, add fillets, change some of the fillet sizes because of interference and whatnot, make slight adjustments. And so there was probably between 3 and 5 prints per each of these, and just doing fitting. And that was not bad. Altogether, it was probably, it's a very small amount of money compared to printing the entire frame, which would have, I could print one frame for essentially 4 of these or 10 of these. Okay, I'm going to move forward here. Now, once I had determined all of my parameters, my most necessary parameters, and I had joined together my necessary parts, performed a combine command, which merged the bodies together. So now I have a single piece. Now that was my intent. I wanted to have a structurally stable one piece to be printed, make it as light and durable as possible. Now, by making a single part, that means that if I have damage to any part of that chassis, then I would have to reprint it. Now, I recognized that that would be an issue, and so I carried on and made adjustments accordingly. I'm going to switch back to my PowerPoint. All right. Now, one of the things that was interesting, something you don't necessarily think about, is the expansive or compressive nature of the material while it's printing. And I found that was a big learning experience, making adjustments. Right. Now, when I've printed the full chassis, I took it outside, or took it inside and flew it, and the first thing that happened is I apparently made the chassis too light, and the quadcopter flew up and hit the ceiling at 1% throttle, was 100% speed apparently, hit the ceiling and sheared off a couple of pins, and then I had to go back and reprint and double check. And when I finally was able to take it outside, one of the issues that popped up was impact on landing. These struts broke off the housing, which would have been all right, except that it wouldn't have happened if it hadn't fallen from 30 feet onto concrete, which was the issue. Went out of range there. Gust of wind caught me, went out of range, and then it just plummeted. Now, here we go. Let me talk about shifting from a single design component over to an assembly. In my particular case, as I said before, I wanted to have a single component because I wanted that structural integrity and lightness. However, I realized that I wanted, since I made the quadcopter frame too light, I recognized that I would have to add some weight and lower the center of gravity. So as a part of that, let me see here. Here we go. I created a bracket system so that I could attach additional components directly to the T or the H junction here. Now I used a projection to bring in this geometry. First I used a construction plane. Working off the construction plane, I extruded the basic shape here. And then I projected the geometry from the H, and I offset slightly. At this point, I had learned enough about the onyx material to know that I was going to get a slight bit of expansion. I would not get a lot of contraction, but there'd be the tiniest bit of expansion. And we're talking 1/4 of a millimeter almost. And so between 1/4 and 1/3. So all the way around, you could have 1/2 millimeter of difference. And I didn't want this to rattle around. I wanted it to connect snugly, but I didn't want to have to force fit it. So let's go into the sketch for that. Okay, let's see. Let's get over there. Now, you can see where I pulled in the geometry from the H junction, and I offset. Oh, here we go. By 1/4 of a millimeter, which is what I had determined was the expansion. And once I had done that, I did that all the way around. And my assumption here is that these spars were going to be slightly expanded, and that as part of the expansion, this the center here would be slightly wider. So instead of doing 1/2 a millimeter, which is what my my brain thought at first, I realized that the expansion would also yield a certain measure of contraction in the center here. And so once I realized that, I set it up just like this, and it fit perfectly. I was actually very excited about that. Let me switch over and I'll show you the picture. All right, now you can see I have a leg mount here. So I have the lower bracket that I just showed you in the model, and then I have an upper bracket, which is essentially just a mirroring of the lower bracket with some addendums. Now these legs, it could be anything. I chose to give landing gear so that I could just have a lower center of gravity. Between those screws and the two brackets and the legs, I probably added 1/3 of the mass of the dry chassis without any components on it. And I lowered the center of gravity somewhat significantly, which helped me a lot with stability. Okay, and I'm going to go back and walk through that a little bit more. Okay. I'm going to switch screens again. Now, one thing that was something that was of great amusement to me was that I made it too light, and I made it so light that it was actually dangerous to the electronics, which is, sometimes you actually achieve your objective in design, and there are side effects. Let's see, I'm going to move forward on my timeline here. And I'm going to turn on that body. What I had to do was, this is another aspect of designing in Fusion, something that I've started to do. I create multiple bodies and then merge them together. Working out of AutoCAD for years, I thought of everything as a single collection of lines, right? Moving to 3D, it took me a while to understand, or really to not understand, but to adapt to the need of breaking things down into steps and features and components. And for example, here I mirrored from here to there, and then I mirrored these two legs across. And then I combine them all together. Now I have a single body. Now I operated, for the purpose of this project and webinar, I operated out of a single component, and I have 3 bodies in here. Now I want to talk briefly about switching from a single part or single component to a assembly. Once again, we're doing internal referencing. I want this bracket, the lower bracket, to be in its own component, and I want to start its own history. So I'm going to hit create component from body, and now I have a component on the high level, and I'm going to double click on the name and call it bracket, because we're very imaginative during webinars. And here, for the landing gear, I'm going to hit create component from bodies. I'm going to rename it landing gear. And then for the chassis, I'm going to also promote that to component status, and I'm going to call it the chassis. Now, the benefit of a component versus a body is now they have their own histories, which means that anything, so if I click on chassis, mouse over it, and then click activate component, immediately the only item in the history is the promotion from body to component. So anything that I do to this model now will have a separate timeline in history from these two, landing gear and bracket. Now, the disadvantage of converting after you've created them is that now all of the history of all of my components is in the what is now the assembly, which is called quadcopter platform. So every bit of the timeline for every single component is in the assembly. Now, if I wanted to plan ahead and I wanted to create a new component now, because I know I have a bracket and I know that I'm going modular, I can go up to the top to the assembly feature, right click on it, and hit new component. And within that tree, I will have a component show up. I can then rename it, and I can call that GoPro mount, for example, if that was my intent. And now I can begin work on a GoPro mount based on my bracket, and I can create that mount. And maybe I want to create a gimbal, and I can bring in parts. For example, let's say I had a very specific intent. I could probably bring in parts from the McMaster car catalog, or I could, try to do it from scratch. Now, within this GoPro mount, let's say I find out that my GoPro mount is actually going to be a gimbal. I could rename it easily enough. But since it's a gimbal, it's going to have hinges and arms, and it's going to need to have joints, and it's going to be fit together and move. But I don't want the gimbal to have a bunch of components like hinges and arms up here in the main assembly. So I can right click on gimbal and create a new component that's nested underneath the GoPro component. So then I can call this hinge number 1, right? And as I go forward, if I have any sub-assemblies, I can divvy up and organize accordingly. All right. Now I am at the end of this demonstration. I'm grateful to everybody who's tuning in and listening to me talk about this project and talk about Fusion. I would love to have a conversation with any of you who are interested in learning more and are interested in similar projects or heard things or saw things during this webinar that brought up more questions. I'd be happy to answer those. Feel free to contact us and stay tuned for more webinars. I'd love any comments. Send us emails and get a conversation started. Once again, thanks a lot. Tune in next time and have a wonderful day. All right, bye-bye.